Hello, today we are programming a thread network over the API. We are setting the network parameter over the API and also sending an UDP package over the API. For this we are using again the NRF52840 developer kit, where you can get it and how to program it and so on. You saw already in the second video from the thread tutorial, so just take a look there if you didn't watch it already. And I have two from them. I mean, we need one for receiving and one for sending. You see my devices here, and we also begin the same like with the command line interface. Yeah, we are going in the thread SDK folder, in the examples folder, going there in thread and copy the command line interface example, put it under my project and rename it to UDP receive. This will be our first project, the receive device. There we're having of course two folders again. We are going to the full thread device folder. So USB we are just deleting, we are not using it. Hex files precompiled we are deleting, and since we are having the developer board, we are just needing there the PCA 10056 folder. The MBR also not interesting for us at the moment, and we are just using the blank folder, and as project we are just using Sega Embedded Studio. So the rest we can delete. There's just still the config file for the SDK. Here that it's more easy to separate the different projects, I rename this and I just call it UDP receive the project, so that when we're having the send we always can see which one we are just open. And then we just open here the project, and here we're having the same. We can rename it, the project file, UDP receive, and also the solution go on rename and call it just UDP receive. When you're using it like this and you're going now to a target and download, you are seeing you have still the old variable here. For this you can just close it and open it again, then it has the right names there, UDP receive. Okay, the main file I make directly a little bit bigger. Let's take a look what we are programming. We have different steps to implement. The first one is we have to initialize the logger module for output and error handling and so on. The scheduler in it, we are needing the scheduler for our thread stack and also the timer, so we have to initialize them both. Then we have to initialize the thread instance, setting the network parameter, starting the network, and after this initialize the UDPs. This means for the receiving device, opens the socket and binds the socket to a UDP-port. Then we're having just our while loop, which checking if there's a thread process or something in the scheduler, and if not, it's going into sleep mode until a new event is happening. Since I'm not so fast with programming sometimes, and it's getting bored when I'm programming so slowly, I copy a lot time something. So, but I will also put a link from the source code, of course, in the description. For the beginning, I delete the most part which we are not needing. So the timer module, timer init we can let, the LEDs init we are not using, the log init we can keep, the thread instance init we can keep, the finalize we are not using, the scheduler init we can let, and the main I will make a little bit more easy, the structure. This part and the lets we take away first. We are not checking if the reset button is pushed, so we delete this. The finalize, of course, away. Oops, this was one braces too much. So the while loop, of course. So now we're having our first structure. So, and let's go over it. Like I said before, we're having the logger init. The logger init just initialize the logger module. Yeah? We are setting the default backends, which means the RTT, where we are getting our output from the debugger in Sega Embedded Studio. The next step is the scheduler init. When you're looking at the top, we're having here two variables, the scheduler queue size and the scheduler event data size. The size are quite good predefined, so just keep it like this. The scheduler init just calls the macro app scheduler init, and then we give as parameters the data size and the queue size. Afterwards, we're having the timer init. In this function, we are just initialize the app timer with error handling. I make the comments away so it's better overview. So, and in the next step, we initialize. We take a look at our steps: log init, scheduler init, timer init, and then we initialize our thread instance. This we're making a little bit different than here. We also defined, of course, the configuration parameter. We also let the radio mode on when it's idle, the radio is then on. Here, auto commissioning, we're setting on false, since we want also to put our modules in the when you're making auto commissioning on, it's checking the SDK config if there is information stored. If then it's taking this parameter. If there is already something stored, of course, in the non-volatile memory, it's taking this parameter. Auto start disable also on true, since we want to start our network by our own. This callback function I deleted. We are not interested in it, and also not on the LED. It's also not the status LED. So that we are just initialize the thread instance and the command line interface. Afterwards, of course, afterwards in the next step, we have to set the network parameter. This function is a little bit bigger. We just set network parameter and the function I just copy it from here. For this I am using a few macros. I put it on the scheduler macro, define my thread pine ID. I can call it coffee, for example, coffee. And here also the extended PAN ID. So I have to make byte per byte, of course. These are the parameters from the IEEE standard. Yeah. We're having here our 16-bit PAN ID and the 64-bit extended PAN ID. The network name is normally default Open Thread. We just put here my wireless sensor network WSN. In this parameter you are free. It should be just unique to the thread network in our area, yes, that there are not two thread network with the same parameter. The function itself, I will also copy it. Since this is a little bit longer, it's not difficult. We go there also step for step. So you're seeing here the function set network parameter. We taking an instance from our thread stack, so that we can control our thread instance. We are checking here if there is a dataset already commissioned. This means if there is something in the non-volatile memory, then it's taking the dataset from there. Only if not, then it's setting there a new dataset. A dataset is just a collection of parameters for a thread network in Open Thread. This means also when we want to make a new network with new parameters, and we used our devices before, be sure you erase also the non-volatile memory. That the new parameters are also taken. Then we're generating a new data set. We just initialize it with 0. Setting my active timestamp on 0. The channel we are setting on 11, and the channel mask we let here. This one is default. The PAN ID we just defined up there, and also the extended PAN ID. We just copy it inside there. The master key we could change here if we want to have a secret network, of course. But then we have also, when we want to sniff later, we have to change in Wireshark's master key for sniffing. Yeah? So I just let it the default one from Open Thread. That this is 0011 and so on. You can see it in the third video where I explained the sniffer part. That's the network name we are setting, and the mesh local prefix. Yeah, I'm using now this one. You are quite free to define it. Just be sure that the first part, the mesh local prefix, fits to the thread specified mesh local prefix. Then we're setting the active data set, and afterwards this parameter is taken. The next step what we have to do is to start the network. Starting the network means enables the interface. You know it maybe from Linux. You have to the interface if config up to open the network interface, and afterwards we are starting the thread network. There's a function for this. I will also copy it from here. It's a little bit faster. So function thread network start. Again, we are taking one of the OT instance, and then we are enabling the interface, and we are starting the interface. Yeah, we're setting the parameter to true. When you're using the command line interface and the network is not automatic started, then you would have to put in the command ifconfig up, and afterward thread start. So this is equal to this part. Yeah, we have only to set thread network start. Our while loop, you saw it already before the process. We are having the thread process, our scheduler, which will be always called if there is this thread process, and will be executed. Also, if there is something in the queue from the app scheduler, it will be executed. If then afterwards the logger is empty, then the thread device try to sleep. So the last thing what we are needing, take a look back here, we just started the thread network. We have to init the UDP, so open a socket and bind the socket. This part, I will also copy it, I think a little bit down here, UDP init. What's happened here, we define first an error, then we're getting again our thread instance, then we define a UDP socket, a socket address. The socket address, we are don't setting an IP address, we want just to bind to the address 1234 to the port. So we initialize everything with 0 by just settings parameter mport, which is for the destination port, the source port when we are receiving 1, 2, 3, 4. Then we are using here a quite nice trick for error handling. We're doing a do while loop, but the while is always false. This means this part is only running once, but when there an error occur, we are breaking this loop. Yeah, and this is what we are doing. We are open the UDP, and we are as parameter we're giving the instance and the socket, and also a callback function which is called when a package is received. Yeah, we have still to define this. If there is an error occurred, then of course it will break the do loop and will not execute the rest of it. If no error occurs, then we bind the socket with the socket address, and we're checking again if there's an error. If there is one, then we just print it out over the logger module, yeah, with the error number. So the last step what we have to do now is handle UDP receive. We have to set it before, of course, because we are already using it here, so it has to be defined before. The handler, we have there a lot of parameters, context if there are also additional parameter, but normally we just have the message and message info, and for us we are just checking how long the payload is. This we get with the function OT message get length, the whole length of the message, and also minus the offset. This means the additional parameter. And then we're defining a jar buffer, reading the message, and then store it in the buffer as long as the payload length is, and we're starting at the point from the offset. Yeah. And afterwards we just print it out over the command line interface. This means where over PuTTY we can then get the information from the package, what is the payload. We have now to add a few parameters. First the BSP thread here we can delete, we don't need this header anymore, but here we have to add 2 header files. Since we are using UDP functions, we have to implement also the UDP header, and as last, since we are using the function for the command line output, we're using the header files for the command line interface. So now we can build our project. And transfer it to our device. Yeah, connect it first, choose your device, and then erase all, that the parameters are erased which are already stored, and then download the file. Yeah, we can now check it one time. Yeah, I open PuTTY. You're seeing the prompt, so the device is started, and I can just check dataset active, and we're seeing here that this is now our mesh local prefix, the PAN ID which we set before, and our network name and our short PAN ID. Now we have to implement the same, of course, for the sending device. For this, I'm just copy our project, what we just did, the UDP receive. I make a copy and just call it send, UDP send. Go inside, open the function here, rename, of course, first the project, send, oops. Yeah, this is quite helpful, since if you are not renaming it, you see normally here you're having still the receive project. We have also to rename this. When you're having two devices and you're having the same project name, it can be quite confusing sometimes. Rename it and send. Save all. But since this is still the same, I just reopen it, and now I see also the target is here. Now send. Make it bigger again. I mean, the most part will be the same. Yeah. Just take a look. This was our receiving device, and the sending device will be just the UDP init will change, and we don't bind UDP-Port. We just initialize a button and register a button handler which executes an UDP-send function. Make this big again. And what we don't needing anymore, of course, is the UDP init and the handle UDP. Instead, we are needing an send function, UDP send function here, which open also socket and sending some text. Yeah. We need also an arrow here. The text which I want to send is just text to send, so nothing special. We get our thread instance, initialize in socket, initialize the message info. What we are doing now, we don't searching the IP address from the device. We're using a broadcast address. The broadcast address from Thread is FF03 and then colon and 1. Yeah, so we're using the function OT IP6 address from a string to getting then the right format. The port where we want to send something, we defined before 1, 2, 3, 4, and then we're doing again the same trick, do while loop, and we open the UDP-port. If there's no error, we are creating a new message and adding our text to this message. Here's a buffer which we stored before. And if there's no error occur, we are using the function UDP-send and sending the message, and afterwards we are closing the UDP port or the socket again. If there is no error, we just give out over the command line interface information that the message is sent, and when there is an error occur in the debugging mode, we are saying then UDP-send error. After we implement the UDP-send function, we just have to register a button. For this we have to add here, instead of the UDP-init, the BSP init and registers the button handler, checking for an error, and the function itself, it's also quite easy. The button handler, when the button is pressed, then we are using button 0, so on the developer board it's button 1. Then we are calling the function UDP-send. This is all actually, and we just build this. Okay, for this I forgot we are needing here the BSP, include the header file, BSP header, since we are using a button. Then we connect to the device. Be careful that you're choosing the right device. Then erase everything, that also here as a new parameter are taken, and transfer the file. Now I open a second putty here terminal, and now you're seeing here down this is device 1, so this is this device. The COM4 is device 2. I can also check here the data set, having the same parameter, and when I click now the button here, you're seeing here send, and here we're having text to send. Can click it more time, and every time a UDP package is arriving. We can of course also capture the package and seeing if it's working. How to capture you learned already in the third video. If you don't know how to do this, take a look at this video. You're needing the USB dongle. Here, I have it here, if you see it, the sniffer dongle. I just can put then here. You're seeing that 4 UDP packages are coming. This is because it was a broadcast sending, and then since this is not confirmed package, it's just sending 4 UDP packages. You can take a deeper look here inside using UDP, support 1, 2, 3, 4. The payload is here, and we're seeing here text to send. It's actually quite nice what we are able to do. We could then also connect a sensor, for example, and sending temperature data from one module to another module over UDP. But of course it will be much more interesting if we are using protocol from application layers, CoAP application protocol. This makes a client-server structure there, like we know it from the web server, from an HTTP web server. This we will see how it works in the next video. Thank you for looking. I hope you like it and understand it. See you.